Alright, so today what we're going to try and do is we're going to try and put triangles in the circle. So today we're going to use the unit circle, and more specifically we're going to put triangles in the unit circle as points on the circumference. Okay, so we're going to put triangles in the unit circle as points on the circumference. What the heck does that mean? Well, I'm going to show you as we go on, okay? So first of all, what do we know about sine? We know sine, let me just go ahead and draw a triangle here. We know sine is the opposite over the adjacent, right? I'm sorry, opposite over the hypotenuse, right? But if we were looking at it as a point, then on the graph, if you make a point out here, and I'm going to draw my circle in, this should make a lot of sense. And this is a point, and every point has some x and y value, right? Okay, how am I doing? I want this to make sense. So the two triangles are pretty much the same triangle, except we're going to label it differently. We know sine is opposite of hypotenuse, but we take the same triangle and put it on an xy plane, where this is the x-axis and your y-axis, right? Then what happens is this. If this is a point, then to get to this point we'd have an x value and a corresponding y value, and we have a radius. This is also on the unit circle, okay? So then sine, which was my opposite of hypotenuse, is now my y value of my point over my radius. That's important. The cosine, which is my adjacent over my hypotenuse, right? We know that. This time, the adjacent is my x value, and my hypotenuse is my radius, so we're going to rewrite this as x over r. X value of the point or the radius. Tangent we know as the opposite over the adjacent, but as far as a point in the coordinate plane, it's going to be an x value and a y value, but it's going to be the y value over the x value. So it's the y value of the point over the x value, okay? Now the cosecant is just the reciprocal of sine. It's just the cofunction of sine. So it's going to be the radius over the y value. The secant, which is the cofunction of cosine, is just going to be the radius over the x value. And the cotangent, of course, is the cofunction of tangent, is going to be the x value over the y value. Okay? Now, let's go ahead and shift down to problem number 1. Okay? So, we're going to apply this stuff. I've got a point. I see I've got a point here. And for my point, every point has some x and y value, right? Okay, I agree with that. So I do know in this example, my x value is -3. My y value is 1, right? xy for my point. That makes sense. What I need is this radius, because I've got the x, I got y, but I don't have the radius. So what I'm going to do is just use Pythagorean's theorem. So if I create a right triangle, right, I can use Pythagorean's theorem. Now Pythagorean's theorem is a squared plus b squared equals c squared, right? A squared plus b squared equals c squared. But I'm going to rewrite it as x squared plus y squared equals r squared. Same exact formula, except for x value, y value, radius, right? Same exact formula. It is the Pythagorean theorem. Okay, well, I need to find the radius in this example because r equals, I don't know, r equals question mark. So if I'm going to do that, I've got my x value, which is my -3 squared, plus my y value, which is my 1 squared, equals my r squared. And then I'm just going to solve for r. So I'm going to go, okay, that's a 9 plus 1 equals r squared, or 10 equals r squared, or r is the square root of 10. Okay, Well, now it gets easy. Seriously, now it gets easy. Because once you have x and y and r, we just plug them in. We just plug them into what this says, right? So if I want the sine, I'm going to take 1 over the square root of 10. If I want the cosine, I want the negative 3 over the square root of 10. If I want the tangent. So let's just do that. I'm just going to take these numbers and plug them into our ratios, okay? Ratios is a fancy word for fraction, right? So the sine of theta, theta would be right about there. The sine of theta is going to be y over the r, so it's just 1 over the square root of 10. The cosine of theta, well, cosine's the x value over the radius, which is going to be a negative 3 over the square root of 10. The tangent of theta, which is the y over the x, is just going to be my 1 over negative 3. How am I doing? Am I going too fast? Slow down for a second. Hopefully, give me a thumbs up if this makes sense. I mean, it really is the same stuff we did like a month ago, except for it's just using x's and y's and r's instead of opposite, adjacent, hypotenuse. Same stuff, right? And then, of course, sine, if I want to find the cosecant, cosecant's the reciprocal of sine, so it's just going to be the square root of 10 over 1. And secant of theta is just the reciprocal of cosine, so it's just going to be the square root of 10 over negative 3. And then cotangent, which is the reciprocal of tangent, which is going to be negative 3 over 1. Pretty easy? Okay, let's look at the next example. Now it says, what's a reference angle? So find the reference angle. So if I take a look at this example here, okay, I want you to look at this example. This angle right here, that angle right there could have been 150 degrees, right? I mean, I didn't measure it, I didn't use a protractor, but this could be 150 degrees, right? But I didn't use this angle at all because I wanted a triangle. Ever see that? I mean, I didn't use this because there's no triangle here. So if a reference angle is going to be the angle that makes a right triangle on the x-axis. So if I take a look at this picture right here, and I redraw it so that my 150 degrees is here, then my reference angle is right there. And I'm going to give you a definition. I'm going to write it down. So the reference angle in this case is 30 degrees. That's my reference angle. So the definition of a reference angle, it's the acute angle on the x-axis. So it's the acute angle on the x-axis. That's my definition of a reference angle. And then, why is that important? Well, you don't do right triangle trig with 150 degrees, right? I'll say it again. You don't do a right triangle trig with 150 degrees. But you do it with a 30 degrees, and that's why you need the reference angle, because it creates a right triangle. Thumbs up on that. Makes a little bit of sense. You can't do a right angle with 150 degree angle, but you can with this 30, okay? All right, ready to turn the page? All right, now, to turn the page, we're going to go ahead and use the unit circle. So before I do this, let's take a look at the unit circle. All right, now, I'll show you a picture. Where's my graph paper? I need a piece of graph paper. Perfect size, okay? So, the unit circle technically is on a graph, okay? Technically it's on a graph, okay? So I want you to see, if I had x-axis, y-axis, right? And I drew a circle, unit circle, radius 1, okay? Circle, radius 1. It would be like this. That's really little, right? You guys agree? It's really little. So what we've done is we've just like, boom, popped it up. This circle here is this circle here. Okay, if that's the case, then it's on the coordinate system. So then this is a point. This is a point right here, and the point is at the point 1, 0, right? That point there is that point there, 1, 0. This point here on the y-axis is at the point right here on my unit circle, and it's the point 0, 1, okay? This point right here, which is on the x-axis, is also this point right here, which is at the point -1, 0, right? And this point right down here, way down here, is at the point 0, -1, which is this point right here at 0, -1. Okay, now I'll pull this away because I want you to know, everybody agrees that this little circle on the graph is this circle here. Thumbs up. Except for you can't fit all of this on that, right? You can't do it, so we just blew it up. Okay. Now these also have points. In fact, if we go back to that warm-up we did, we've got the square root of 2 over 2, square root of 2 over 2, radius of 1. The coordinate of this point is square root of 2 over 2, comma, square root of 2 over 2. Please put that down. Now that would be right about here on the unit circle. You can see where it's not exactly on the grid. It would be like some kind of decimal answer, right? But that little point right there is that point there, okay? Now, the same triangle's over here at 135 degrees, but it's just flipped over. In fact, you can see that there's a triangle here, but it's going to be going back, so it's going to be at the coordinate negative square root of 2 over 2 and a positive square root of 2 over 2. Because if I had to draw the same point, I'd go back that much and then up that much. Down at 225 degrees, if I wanted to graph this point, it would be going back that much. Same triangle, exact same triangle. In fact, I'll try and draw the triangle and you guys can see that. And don't draw this, I just want you to see it though. My pencil will work. But technically there's a right triangle right here. And I took this right triangle and I folded it over here. Now I'm going to take this right triangle and draw it down here. So I'd go back a square root of 2 over 2 and down a square root of 2 over 2. So the coordinate of that point is a negative square root of 2 over 2 and another negative square root of 2 over 2, okay? And then, of course, there's another 45, 45, 90 triangle right here, but it's just the same triangle but flipped down. So the coordinate of this point would be over square root of 2 over 2 and then down a negative square root of 2 over 2, okay? So those are points that are all along this little itty-bitty circle, but there's no way we'd be able to fit all that stuff on here. But we do know that this is the circle we're drawing, okay? Now, the 60-degree angle here has the same coordinates as this 60-degree angle here, okay? So we draw that one in. And don't draw that, because I'm going to erase these things. But there's technically a right triangle here, okay? We know the coordinate of it is at 1/2 and square root of 3 over 2. So I'm going to put that in my circle. So the coordinate right here on the point at 60 degrees is over 1/2 and up the square root of 3 over 2. Now there's another exact same 60-degree triangle, but over here, if I just flip it over. So to get to that point, I'd go back 1/2 and I'd go up the square root of 3 over 2. And there's another of those 60-degree triangles way down here, but it would be back and then down, so both of the values would be negative because I'd go back a negative 1/2 and I'd go down a negative square root of 3 over 2. Okay, that's the coordinate right there at 240 degrees. And then finally, there's another one way over here at 300 degrees, another, but this one's going to be over 1/2 positive and then down. So my coordinate here at 300 degrees is going to be a positive 1/2 and a negative square root of 3 over 2, okay? How am I doing? Okay, now let's put in the last triangle. The last triangle's right here. All right, there's another right triangle right here. This is my 30, 60, 90 triangle, and that's going to be that triangle right there, right? We drew this triangle right here. Same triangle. It's going to be over square root of 3 over 2 and up 1/2. So the coordinate at this triangle would have to be a over x value of square root of 3 over 2 and then a y value of up 1/2. There's another 30, 60, 90 triangle over here at 150 degrees, but it's flipped over, so it would be a negative square root of 3 over 2 and a up positive 1/2, right? And there's another 30-degree triangle right here, but it's in quadrant 3, so it's got to be back and then down, right? So it'd be negative and then negative to get to here. So it'd be a negative square root of 3 over 2 and a negative 1/2, okay? And then finally, the last one, we have the last triangle here. This is my last 30-degree angle here. It's going to be a positive, because you're going to go over and then down, positive square root of 3 over 2, and then a negative 1/2, okay? Right? How am I doing? So this is our circle. Now, we're going to use our unit circle to do trigonometry, because we know that the sine is the y over the r. We just learned that, right? But since the radius is 1, the sine value is just the y value of the coordinate, okay? The cosine value we know is the x over the radius, the x value of the radius. We learned that in our notes, but since the radius is 1, it's just really just the x value, okay? The tangent really is the y value over the x value, okay? And that's all we can do with that, okay? But we'll try and make some simplifications, okay? How does this help us? Well, hold on. Let's go back to my notes. Okay, let's go back to my notes. So, go back to the notes. Example 2. Am I going too fast? Tell me to slow down. So all of my sine and my cosine values are here, okay? And I'm going to have you just look as soon as you're ready. But Ellie, I don't want to rush you, okay? I really want you to understand this, because it's super easy. It really is, okay? The sine is the y value. So watch. Are we watching? Olin, you watching? So you're ready. Sine of 30 degrees is 1/2. You can check it on your calculator, but it is. Sine of 30 degrees is 1/2, because you go and you pick out the y value, okay? Right here at 90 degrees. Cosine of 90 is 0. How do I know that? Because cosine is the x value, okay? Check this out, okay? Sine of 120 degrees. Sine of 120 degrees, y value, square root of 3 over 2. It is. That's the exact value. So if I do these, so if I go to example 1, sine of 30 degrees. So I go to 30 degrees, here's 30 degrees, and sine is the y value. Sine is the y value. What's the y value of the point? 1/2. That's the answer. 1/2. Boom. In fact, we can check it on a calculator. It is 1/2. Cosine of 45. Cosine is the x value of the point, right? Every point's got some x, y value. Cosine is the x value. So go to 45 degrees. Go to 45 degrees. What's the corresponding x value? Square root of 2 over 2. That's the answer. That is the cosine of 45 degrees. It's the exact answer. Tangent of 150 degrees. So I go to 150 degrees. And tangent is got to be the y over the x. Okay, now we're going to make this easy. Okay, since we use sine, cosine, and tangent exclusively, I'm just going to put the tangent values on our circle to make it easy, because this is a lot of work, okay? So here we go. Instead of doing it this way, let's put all of the tangent values on the inner circle. Okay, we're ready? Watch. Let's add these, okay? And I'm going to add these in, I'm going to put it in a different color. I'm going to put it in blue. So these are my tangent values. So my tangent values are in blue, okay? Those are going to be in blue. All right, let's do the easy one. Tangent of 45 degrees is 1. How do I know that? Tangent of 45 degrees is 1. How do I know that? This over this is 1. So I'm going to put a 1 right here. Okay? Right? That over that, square root of 2 over 2 over square root of 2 over 2 is 1. Tangent of 3 pi fourths is negative 1. It's negative 1. Because I know that the square root of 2 over 2 divided by a negative square root of 2 over 2 is a negative 1, right? Tangent of 225 degrees, well, that's going to be positive 1, because you got a negative square root of 2 over 2 divided by a negative square root of 2. That is a positive 1. So I'll put my tangent values on the outside of my circle, just to make it easy for me, okay? Tangent of 315 degrees is negative 1. You see that? Got something over itself as 1, but it's a negative 1 because of the negative, so it's a negative 1, okay? Okay, let's keep doing the easy stuff, okay? All right. So, tangent of 0, or 360, is the y over the x. 0 over 1 is 0. That's the tangent value. Tangent of 180 degrees is 0 over negative 1, which is also 0. That's my tangent value, okay? Tangent at 90, you are going to have to divide by 0, make Cookie Monster unhappy. You cannot divide by 0. So it's undefined. Tangent value is undefined, and the tangent value is undefined at 270. Check it out. Check it out. Tangent 90. Let's see what it says. Oh, got to turn it on first. Tangent 90. What does it say? Domain error. It does not like it. So you can't, and tangent 270. Can't do that one either. Tangent of 270. Same thing. It's just going to give me a domain error. Oh, no wonder. Too many numbers there. Tangent 270. There you go. Domain error. Okay, can't do that. Okay, now let's go back to this one. Okay, at 60 degrees, it's going to be square root of 3 over 2 over 1/2. The 2's will cancel, and the answer is just the square root of 3. Okay, tangent of 60 is square root of 3. Tangent of 120 will be the same thing, but a negative square root of 3. Boy, this is a longer lesson than I wanted it to be. Sorry, guys. Tangent of 240 degrees is going to be a positive square root of 3 because it's got the negative divided by negative. And tangent at 300 degrees is going to be a negative. It's going to be a negative square root of 3. We're almost done. I've got one more thing to put up there, and then we'll be done, okay? That's a lot, huh? Okay, now, last one. This is the one we were doing in our warm-up, okay? This turns out to be 1 over the negative square root of 3. But if we rationalize it, it's going to be negative square root of 3 over 3. And that's the answer we want on a unit circle. So at 150 degrees, the tangent value, which I'm going to put out here, is a negative square root of 3 over 3. At 30 degrees, you've got the exact same ratio, but it's positive. Square root of 3 over 3. At 210 degrees, you've got the exact same ratio, but it's a negative divided by negative, so it's just going to be a positive square root of 3 over 3 for my tangent value. And finally, at 330 degrees, you've got the exact same ratio again, but it's going to be a negative square root of 3 over 3. All right. We have completed the unit circle. We're not going to put anything else on it. That is the unit circle. Everything's there. How does it help us? Well, let's go back. Let's go back to our notes. You ready? Let's do some trigonometry. Sine. Okay. Sine is the y value. So I go to my negative 60 degrees is rotation. It's right here. What's the y value? Negative square root of 3 over 2. Okay. Negative 60 degrees is a rotation back 60 degrees. We want the sine, which is the y value. The y value is negative square root of 3 over 2. That is the answer. Cosine of 420. Well, that's like 360 plus another 60. I want the x value. So I'm going to go 360 plus another 60 puts me right there. And I want the x value, which is 1/2. So the answer is just 1/2. Tangent of 90. So I go to 90 degrees. The tangent value is undefined. Oh, pi 4. So that's okay. Those are on my unit circle, right? I just have to find them. Sine is the y value. Pi force is there. It's an angle, right, in radians. What's the y value? Square root of 2 over 2. Cosine is the x value. 2 pi thirds on my unit circles is there. There's 2 pi thirds. I want the x value because I'm looking for the cosine, which is my negative 1/2. Tangent. Okay, tangent of 5 pi fourths is on my unit circle. 5 pi fourths is way over here. See 5 pi fourths? The tangent value is 1. Sine of pi. Pi is the y value of my point. So I go to pi, which is here. My y value is 0. Cosine, which is the x value. Okay. Now negative pi thirds, again, is a rotation. If, okay, everybody watching? If pi thirds is here, right? If pi thirds is here. A negative pi thirds is just a rotation to here. It's just a backwards rotation, so it's right here. I want the x value because I'm looking for cosine, so the answer is 1/2. Tangent of negative pi fourths, okay? The tangent values are on the outside, but negative pi fourths, again, is a rotation. If pi force is a rotation to here, pi force rotation here, then a negative pi force is a rotation to here. I'm looking for the tangent value, which is -1. Okay, that is what I have for us. Homework is going to be out of our workbook today, and I'm going to show you what it is. It's not that hard. It's actually much shorter. I think it's 8.3. I'm sure it's 8.3. 8.3. 8.3, there it is, 8.3. Yeah, I just want you guys to do 235, page 235. We'll do 1 through 7 all, okay? And you have time to get this done because it's really a super easy assignment, okay?